Hey YouTube family, welcome back to the session 7 of Java Full Stack Made Easy. It took some more time for me to post this video. Uh, I wanted to know how many people are actually following the series. If you are really following the series, do comment on my videos and subscribe to my channel so that it motivates me to make more such content and I can deliver timely content if people are really following me. Alright, so without wasting much of the time, let's go back to what we discussed in the previous session and what we will be discussing in this session. So in the previous session, we talked about the string buffer and string builder. We spoke about the difference between string buffer and string builder. We have seen how string buffer is thread safe, which makes it slow, and how string builder is fast because it is thread unsafe. And in single threaded environment, we use string builder. Multi-threaded environment, we use string buffer. So let me just clean this up, everything in here, and let's go ahead and let's talk about the branching of statement in this session. So in this session we'll be talking about the fundamentals of the programming. So one such fundamental is if else, that is branching of statements. We can either make use of if else or we can go for switch case. We'll also be talking about the logical gates in this. Okay, so let's also I'll talk about the reading of data from the end user in this session itself. So I want to read the data from the user. I can take the data from this string arguments, or I can ask the user to enter some data and read the data. So let's go for the scanner first. Okay, scanner SE is equal to new scanner, and I want to read the data from the keyboard. So I'll go for the system.in here, and then we'll try to read the data. First, let's just read the data and print it. So if I have a string se.next, if I use, I'll directly be reading the string. Okay, let's just call it as str equals to and system.out.println. We'll just print whatever we are reading. So let's save it, run it, and see that. So console is not popped up because there's nothing to be printed as for now. So I want to read test, I want to print test. So reading the test and printing test itself. Similarly, this next method takes a lot more things, like if I want to just read the int value, I can directly go for next int and then store that next int value into a int variable itself, like int n1 is equal to next int, n2 is equal to next int again. So that way I can read it and also print it. So let's say n2 is equal to sc dot next int, sorry, sc dot next int, and now that I'm reading two integer values from the user, and if I print n1 plus n2, so it should add me, not concatenate this values. So okay, let's run this and let's open the console, enter two numbers, that is 12, and let's enter 3. So 12 plus 3 is 15, so the result is 15. So this way we can read any type of value from the user, either an integer value or a string value. So based on the value that we are reading from the user, we have to choose the next method. So it can be next int, it can be next float, it can be next double, it can be simply next to read the string. If we want to read multiple lines, so we can also give something like next line. Okay, so as for now, I wanted to just read an integer value. Let's say int age is what I want to read from the user, and let's give a message to the user so that user knows what he has to enter. In the previous example, I did not give anything to be entered by the user, right? So I'll also keep this as it is so that you can try this in your machines as well. So before that, you can give a message, enter two numbers, so that it will be easy for you to get that. Enter two numbers to add. Okay, so now you will get a pop-up, console will be popped up, and it asks you to enter two numbers like 12 and 3. You'll get 15 for this. So this is a simple example about the scanner. How do we read the data from the scanner? We can also read string values and the other type of values using scanner. So let's get this, and let's create the day 7 for this particular session. So day 7, this is my demo 1, and this is about what? Scanner. Okay, so I'm reading something and just printing that. So let's save it and let's go back to what we were doing here. So now what I want to do is I want to just let the user enter a number. Let's say I want the user to enter an age, and based on the age I want to check whether the employee is selected or not. So let's go here and system.out.println. What I want to do is I want to read this age. I want to check if this age is greater than 18 or not. If it is greater than 18, I'll say the employee is selected. Okay, else I just want to say that the employee is rejected. Just a simple if else where I'm branching the statements, any one of them will be executed. Okay, let's save this and see how things work. Let's run this, and the age of the employee I'm entering 20, so user's age 20 means selected. That's fine. So let's run this once again and see what happens if I enter the age as 15. So 15 is rejected. So looks good, right? So this is a simple branching of statements. So I'll also put this into the repository as a simple branching of statements file. So this is my demo 2. Okay, if else. Let's put it here. So in the same example itself, what I want to do is I want to add one more condition, that is I want to bring in something like the age has to be more than 18 and say age should be less than 50. So that is what I want to implement in here. So you might have always noticed that people give single ampersand and double ampersand, right? So let me give double ampersand there and understand what it is going to be. Let's save this and see how things work. So I run this piece of code and I enter the age as, let's say a valid age would be what, 25 is a valid age, which is more than 18 and less than obviously 50. So it is selected. And in this case, if I enter something like 16, which is not a valid age, so I get rejected. But there is a difference when writing a single ampersand and double ampersand. So if I write a single ampersand now and enter the same value 16 here, what happens is this program will be a bit slow comparing to the previous example. Now you might say, how this is slow? It's giving me the same result. For 16 it has to be rejected, and for more than 50 also it should be rejected. Why a single ampersand and double ampersands are used, and what is this all about? These this double ampersand is called as the short circuit logical AND. Okay, and there is a short circuit logical OR as well. So let us analyze why this short circuit logical AND is always used and why is it preferred. So let's go to the drawing board and understand that. So what we have is we have the comparison operators, which I am saying here, the logical gates. We are talking about an AND logical gate. We also have a OR logical gate. We have a NOT and then we have an XOR. So my focus is on AND as for now, and there are only two short circuit logical operators available for us, that is for AND and for OR. There is no short circuit logical operator for NOT and XOR. So we'll see why is it not there. So let's see the conditions. Obviously you should be knowing this. In case of AND, if both the conditions are true, then only the entire expression will be evaluated through true. And in case of OR, if both the expressions evaluate to false, then only the result will be false, right? So in all other cases, in true, in ampersand, it will be false. In all other cases, in OR, it will be true itself. Like for example, I'll give you maybe one or two more. Suppose if I have a false and true, then the entire result obviously is going to be what, false itself. The rest all things will be false itself. If you give false, false will be false. Like if I give something like false and false, the entire result is going to be false. If I give it as true and false, the entire result still is going to be false itself. Because in the AND gate, if both are true, then only it is true. In all the other cases, it is going to be false itself. In false, in OR, if both are false, then only it is false. Else in all the other cases, it is going to be true itself. So if I say true and false, then the entire result is going to be true. And if I say true comma true, then also the entire result is going to be true. If I say false and true, then again the result is going to be true itself, right? So this is how it works. Now if suppose I ask you to give me the result of this in maybe an AND gate, suppose if I give you just one single thing, false, and then I tell you AND, I don't know the second expression. So will you be able to predict the result for this? You will say, yes, we will be able to predict the result. Why is that? That is because we know that in case of AND, if both are true, then only it is true. Now, first is false, so I can say the result is going to be false, irrespective whether the second one is true or false, right? Even if the second one is true, still the result is going to be false. So we are focusing on the entire result of this. Similarly, in case if it was something like this, in our case, if first one is true or the second one, we don't know the second value, so we be able to predict the second result of this? Yes, we will be able to predict the result that is going to be true. So this way we can predict the result based on just one expression, not both the expression, right? So in certain cases we want to evaluate both of them, in certain cases we don't want to evaluate both of them, right? So this single ampersand and double ampersand gives you that difference. Single or and double or gives you that difference. That's why most of the time you might be seeing double or itself and double ampersand itself. So this one is fast because it is not evaluating the second expression. Based on the first expression itself, it is giving you the result, but not always. Okay, if the first expression was something like this, suppose if the first expression is true and you have written a double ampersand and the second expression is false, obviously if the first expression is true, it has to go and evaluate the second expression. You cannot predict the result now, right? If the first one is true, you cannot directly give the result because the second one might be false, might be true. If the second one is false, the result is going to be false. If the second one is true, then the result is going to be true, right? In some cases you will be able to predict the result of and or only by looking at the first expression. That's what our short circuit logical operators do. So let us understand that with an example so that it will be easy for you to understand the difference between the single ampersand and the double ampersand. Okay, so I have already posted about this if else into the repository, I hope. Let me first check that. So demo to if else is already posted. Now I will give you the difference between a single ampersand and a double ampersand. We have already seen that whatever I give based on the values itself, the result is being displayed. So what I'll do now is I will take maybe one variable I'll take here. Let's say that is a Boolean variable which I'll make as false. Okay, let's say a Boolean variable x is equal to false. Okay, so let's call it as checked or maybe tested or something. Let's call it as tested equals to false, and instead of this age is less than 50, what I'll just do is I'll add an expression here to tell you that I want to see in Java it is also possible to initialize the value inside an if. So I can do something like this here, tested equal to true. This is what I can do here. Okay, so I am just evaluating the value, I am not checking the expression. The second part is not checking the expression, it is just about the value is tested or not. Okay, so here what I am checking is if the age is greater than 18, then make the tested value as true, and at the end I will check what is the value for this tested, whether it is true or not. So let's just say tested. So save it and run this piece of code and see what happens. So enter the age. I am entering the age as let's say 20, and it says the value of tested is true. And now what I will do is, because the first expression is evaluated to true, second expression is checked, and it has made that value tested to true. Now what I will do is I'll run this again and I will enter the age as 15. Now I'm entering the age as 15. So once the age is entered as 15, second expression should not be evaluated. If the second expression is not evaluated, the result of this tested should be false, right? It should not become true. So let's see what happens. So I enter this and it is giving me false. So this proves us that if in case of ampersand, that is if I am using double ampersand at that time, if the first condition is false, then the second will not be evaluated at all. If it is a single ampersand, then we will get the different result. So let me just go here and write a single ampersand. Now you will notice that in both the cases I will get the tested as true itself. If suppose I am giving a true value, obviously it will be tested. In this case, even if I give an initial value as false, like age 10, I will still get the tested as true. So tested true means in this case, when I am using a single ampersand, what is happening is it is evaluating both the expression. In case if I am using double ampersand, it is not evaluating both the expression. So what I will do is I will copy the same thing here and I'll put this in comments. So what you do is you uncomment one after another and check the result. Okay, so I'll just put this under comments. This is fine for me, And now what you do is when you run this piece of code, what you do is you try and give the initial value as false. That means the first expression here, age is greater than 18 is what I am checking. So you give the age as 14. So when you are giving the age as 14, the first expression is evaluated to false. It goes to the second expression, makes tested as true. Then it gives you rejected, result as rejected, comes to the else block and gives you the value of tested as true because both are checked here. So let me enter and give you the result. So here is the result. So you can see that it is giving the output as rejected and giving you the value for tested as true. Same thing I'm doing here as well. So I'll put this under the comment section, and I'll put this part under the comment section, and then I'll bring in this here, which is same, right? Let's bring that here, and let's simply try and add a double ampersand. Now let's give the same result itself. So I'll run this and give the same result as 14 again. So previously what was happening was, since there was one single ampersand, 14, the first expression was evaluated to false, tested became true, it came to else block, it printed as rejected, and then lastly it printed as the value of this tested as true. That is what we are printing here. Same thing is happening here also. Instead of this single ampersand, I'm using double ampersand. So age is greater than 18, I'm giving it as 14. So this is false, this is double ampersand. So what happens is, only this expression, based on this expression itself, we get the result as rejected. Tested equal to true will not happen, because in double ampersand we have known that if one of the expression is false, the entire result is going to be false, and this will not be evaluated. So you can see that result is false. So this way you can get to know that there is a difference between a single ampersand and a double ampersand. So always, that's why a short circuit logical operator is recommended and it is generally used. So let me add one more file to this. So this is my demo 3, and what's this, double AND. So that's why most of the time you see what, single ampersand and double ampersand itself. Oh sorry, double ampersand itself, not really the single ampersand. Only in a case where you want both the expression to be evaluated, make use of the single ampersand, rare cases. All right. So similarly for OR as well, let's check this for OR. Same thing happens if I'm using OR, so AND not. So let's go ahead and see OR and not. I'll remove this, and let's read the age. Let's say if age equal to, or let's say age greater than 18, or age less than 50, or let's say age should be greater than 18, or the employee age, let's say, in case of OR, what happens is, if any one is true, then obviously it is going to give us the result. Let's say if age is less than 50. So writing this is quite illogical. Now I'll tell you why is that. Let's say selected, and else system.out.println rejected. Why is this illogical? That is, either the age is going to be greater than 18 or the age is going to be less than 50. Suppose, for example, instead of reading this value now from the user, that is, it is taking more time for me to enter the value and everything. So I know that I have shown you how to enter the value. Now what I'll do is, instead of doing all this, let's keep it simple. Okay, I'll just give the age as 16. So when I give it as 16, is 16 greater than 18? No. Is 16 less than 50? Yes. So always it will be selected. Whatever you give, it will be selected all the time. Even if you give a negative value, it will be selected. Even if you give the value as more than 1 lakh or something, the user will always be selected. You give any value here, right? So for any value, user will be selected only. That's because either it will be greater than 18 or it will be less than 50. Even if I give something like minus in the age, it will still be that. That's why I told you this will be quite illogical, because anyone will be true itself, right? So in cases, what I want is either the age should be more than 18, or qualification, maybe something like qualification should be or maybe the rating of the user should be 5. Okay, So int age equals to, let's say, 20, and maybe let's have something like int rating, and the rating of the user is 5. What I want to check is the age should be more than 18 for the user to be selected, or rating should be greater than 4. Okay, so if the rating is 5, greater than 4 is obviously 5, so then the employee is selected, or the age should be greater than 18. In this case, the age and the rating both are greater itself. Now the user will obviously be selected. What I'll do is I'll reduce the age of the user's age is just 12, right, but the rating of the user is 5. Because the user's rating is 5, the employee will be selected, right? So this way, in our case, you can check if any one of the condition is true or not. If any one of the condition is true, then it will be evaluated to true. So in this case, once again, if I give this one like age as maybe if I give the age as 20, so what happens is rating will not be checked because I'm using an short circuit logical operator OR. So it will directly give you that the user is selected. No need to check the rating for age for the user whose age is more than 20. So that's how things work. Okay, and for not, what happens is if a user is selected, then it will make it as rejected. If it is rejected, then it will make it as selected. So what I'll do is I'll just clean this up. Hopefully you have understood how do you make use of an OR. So what I'll do is I'll simply say if this expression evaluates to true, so if not true, then what you do is then return this, or maybe let's write an expression. So instead of directly writing it as true, int age equals to, let's say, 20, and I'm writing age is greater than 18 is what I want. So this, to make it an opposite thing, I'll just make it as not. Okay, so if age is not true, then if age is not greater than 18, then it will be selected, else it will be rejected. So what basically it has done is, now the user whose age is 20 will be rejected, user whose age is 2 will be selected. Okay, not operator, if it is true makes it false, if it is false makes it true. Okay, so likewise an XOR operator can also be used. Okay, I'll give you more examples for this real-time examples. So here we are just testing it. So for not operator, let's write a boolean expression. Boolean x is equal to true, and boolean y equals to true. Okay, and now let's compare x and y, and we'll just be checking whether it is true or false. That means whether it will enter into an if block or a else block. Okay, I'll say x or y. Okay, both are true. Let's run this. In case both are true, it is false. In case both are false, it will still be false. Okay, you can see that. What XOR wants is, both of them should not be same is what XOR says. Okay, now both are different. So in that case, it is true. So XOR, what it checks is both the conditions, both the expressions that you are giving should not be evaluated to the same result. If it evaluates to the same result, then it is false. If it is evaluated to some other result, then it is true. That is what an XOR operator says. So let me just put this XOR for your understanding. You try just changing the values of this and check it. Okay. So this is my demo for XOR. So we'll use these operators into our real-time examples and see how things go. Okay. So now let us understand the next thing. So branching of statements, we have already discussed about how if else works. There can be even nesting of if else, right? So what I can do is I can say int n1 equals to 10, int n2 equals to 11, and int n3 equals to 7. So what I want to do is I want to check which one of the which number among these three is the greatest of all those three numbers. That is what I want to check. So what I can do is I can compare n1 and n2, and whichever is greater I can compare that with n3, right? So that way we can compare the numbers and get the result. So I will say if n1 is greater than n2, then what you do is you again compare it if n1 is greater than n3 also. So if n1 is greater than n2 and it is greater than n3, then system.out.println, what you say is system.out.println, sorry, n1, which will be number, plus is the largest. Okay, or else what happens is if n1 is not greater than n2, then you go ahead and compare n2 with n3. So what I can do now is compare n2 with n3, and if that happens, if n2 is greater than n3, then else n2 is the largest, right? N2 is the largest, and in this case, if n1 is greater than n2 but n1 is not greater than n3, then what happens is n3 will be the largest. N3 is largest here. N2 is greater than n3, then n2 is largest, else n3 is largest. Okay, let's save it and run this piece of code and see. So n2 should be largest, that is 11 should be the largest value, 11 is the largest value. So I'll change it to maybe n1, that is now n1, 100 should be the largest value, 100 is the largest value. Let's now go with the n3, so 777, so that should be the largest value. Basic idea is I could have done this with comparison, like whether n1 is greater than n2 and n1 is greater than n3 or not. Even that can be done. This is just to show you that we can even perform nesting of if else. That means if else can be created within an if else as well. Only to give you that, I have given you this example, or else the same thing can be done in various different ways. So I'll add one more demo, that is demo 5. Nested if else. Okay, so one more example I'll give you about the ladder if else, and after that in the next session we will talk about the switch case. Okay, what is this ladder if else? So when we talk about the ladder if else, as for now scanner is not required to be imported. So for ladder if else, what I will be using is I just want to check the grade of a user if the based on the marks of the user. So marks is equal to, let's say user has scored something like 89. So I'm giving it by myself. You can read it from the user by using scanner. Okay, so my conditions are like if user scores more from 80 to 100, it should be grade A, and from let's say 70 to 80, that is if a user has scored 70 to 79, basically it should be B. Similarly, if a user has scored something like 60 to 69, the grade should be C. And lastly, if a user has scored from 50 to 59, the grade should be D. In all the other cases, it should be fail. Okay, so how do I now check the conditions? What I can simply do is if now if marks are greater than 80 and marks less than 100. Okay, first of all, what I can do is I can also put a condition where if the marks are more than 100 and or marks are less than 0, I can say invalid marks entry. So that will be a better option. So first let's just go for marks is greater than 80 and marks is less than 100. Then system.out.println the grade A. Similarly, I will write one more if marks is greater than equal to is something I am missing here. So let's add equal to, greater than equal to, and less than 80. So grade B. Likewise, I want to add. Okay, I'll add two more expressions, 3, 4. So let's just change the values. It is 60 to what, less than 70, and this is 60 less than 70. This should be grade C and D, and rest all case it is fail. C and D. All other cases system.out.println fail. So let's analyze this first, and then we will see what is the problem in this code. So let me run this and see what is going to be the result of this. It marks 89, so I'm expecting 89 result to be grade A. So it says grade A, and also it gives me the result as fail. Why is that now? It should only give me grade A. That's because, see, every if that I have written will be considered as a separate if block, not as a part of one single if block. So you can see it here. If I'm writing this if, what it has checked is, it has checked whether it is greater than 80 or and less than 100 or not. So this if does not become true. This also does not become true. This also does not become true. When it comes here, it checks whether it is greater than 60 and marks less than 70 or not. So this has become true, and it is checking this as well. So when this becomes true, it is printing it as A. This does not become true, it goes to the else block and it is printing me fail, right? So that is why I'm getting this grade A as the result, as well as I'm getting fail as the result, right? So always whenever you want this to be a part of one single thing, one single branch, so what we can do is, instead of just writing if else, we can go for else if here. Okay, now after writing that else if, what happens is only one condition will be checked, that is if it becomes true, it will not check all the other conditions. So in the previous example it was checking all the other conditions. In this example it is not checking the other conditions. So this way we can make use of ladder if else. So here I'll just make a point, and I'll ask you to, what you do is add one more if to this for marks less than 0 and marks greater than 100 should be invalid marks. So this will be your simple assignment to work with if else. So you try and add one more if block here that checks whether the marks are less than 0. If the marks are less than 0, then it is invalid marks entry. If the marks are more than 100, then also it is a invalid marks entry. So let me put this into the repository. Let's call this as demo 6. If else, if else. Okay, you practice this. See, as a if you want to be a Java programmer, then just watching these videos will not be enough. What you have to do is you have to practice it, then only you will become perfect. And if there are any doubts, and if you're following this series, you do comment in the comment section. You can connect with me on LinkedIn if you have any doubt, or maybe if you're facing any problem. If I have time, I'll give you the solution for the same. I'll try to give as many responses as I can give. Okay, so see you in the next video, where we'll talk about the switch case, and we'll talk about more Java fundamentals, and then we will move to more complex Java features. So thank you. See you in the next video.